Hello, welcome back. This is the third homework sheet discussion, Unit 1 Atomic Structure. This is the last one. So far, we have done the discussion of homework sheet 1, discussion of homework sheet 2. This is the discussion of homework sheet 3. So if you have not completed the first few discussions, better you go there, complete it, and then come back here. And the respective homework sheets, I mean, the link to the PDF of these homework sheets are available in the descriptions of respective videos. So therefore, you can first collect them, try them, complete them, and then check your answers with my discussion. Okay, let's start the last one, homework sheet 3, atomic structure. Here, mainly the questions are based on the writing configuration, periodic table, and the trend shown by S and P block elements like atomic radius, ionization energy, electron gain energy, electronegativity. Those type of variations are there. Correct. Let's go to the first question. State where in the periodic table these elements appear. Periodic table is there. They ask state where. Where I mean here, what's the mainly the group they ask in the first question. So what about the first one? First one, it's given element with the valence shell electron configuration NS2 NP5. So just by looking at this, you can see NS2 NP5 electrons are filled to p orbitals, p sub energy levels. Then I ask you to get the group number easily. You add 2 plus 5, it's then 7. But in the case of p, filling electron to p, I ask you to take this as not 7 but 17. Then where do you place them? Group 17. Below that, you have given the periodic table, the skeleton of that one. So therefore, you can place it, I mean, show it. As example, if I take only small portion, let's keep it here. You know, like this. Next, you are given like this. I take only small portion, the printed part, the complete one is given 13, 14, 15, 16, 17, and 18. This is how we have it. Look at which one is this? 17. So then this is group 17. Group 17, you have configuration NS2, NP5. That way you can just mark it in the given skeleton. Or simply you can put the number A, I mean the symbol. So what is B part? B part is about recording. Yeah, that's recording. B part, element that have 3 unpaired p electrons. 3 unpaired p electrons. So you can have configuration P1, P2, P3, you know. Then when you fill these orbitals with electrons, I ask you to obey Hund's rule. Someone say Hund's rule, someone say Hund's rule. So if there is only 1 p electron, it should be here. If there are 2 p electron, that should be this electron should be here. One in one orbital, the other in the other orbital with the same parallel, I mean the parallel orientation. P3, there are 3 electrons. These 3 should be in 3 orbitals. They ask then element that have 3 unpaired p electrons. Then it should be P3 configuration. That means the element having 3 p unpaired electrons should have the configuration like NS2, NP3. Then again, if you see then here electrons are filled to p orbital. To get the group number, you can simply add 2, 3. We get 5. But in p, I ask you to add 10 more. 5 means here 15, group 15. Then where do you find 15? 16, and this is 15. This is where you get configuration NS2, NP3. That is where you have then 3 unpaired electrons. Then these elements can have 3 unpaired p electrons. C, an element whose valence electrons are 4s2, 4p1. This is easy. 4s2, 4p1. So in this case also it's p. Then we add electron 2 plus 1, it's 3. But here in p, we add 10 more, 13. So then 14, this is 30. This is where you have, then they have given a 4s2. This is ns2 np1. This is ns2 np1. but they have given 4 number. What does this number gives? This number gives the period number. Period number. We learned that one in the theory class. I told you then, to get the group number and the period number, we can use easily the valence shell electron arrangement. Highest principal quantum number gives the period number, and the group number can be taken in this manner. So therefore, this is fourth period. Fourth period. This is first period, second period, you have third period, right? And then you have fourth period. And group number 13. Group number 13, fourth period. So it should be this one, this one, this one, and this one. This is where you have C. 4s2 4p1 configuration is found within this. The D block elements, D block elements are these things. From here to here, group number 3 to group number 12, you have D block elements. Right? So once you go to 6th and 7th period, here we have 2. Those are lanthanide and actinide series. These things are F block. But other than that, all the other should belong to D block. Just marking these areas enough and analyzing the question in this manner, that's complete answer. That's about the first question. Let's move to second question. Answer the following questions. Assume that MS means the spin quantum number, 4 values rather than 2, and that the normal rules apply for NLM. Then there are 4 quantum numbers, as you know. N has the normal rule, means we start with 1, 2, 3 like that. L has the normal values, L from 0 up to n minus 1. We learned that one in previous discussion. So 0, 0, 1, 0, 1, 2. Those are the possible L values. ML also normal, it's 0. This is 0, minus 1, 0, plus 1. This is again 0. This is minus 1, 0, plus 1. This is minus 2, minus 1, 0, plus 1, plus 2, like that. These quantum numbers have normal values. But once you come to MS, spin quantum number, there are 4. What's the normal thing? In the case of MS, there are only 2 values, plus half and minus half. One is the arrangement is like this, up and down. Only one orbital then can have only 2 electrons according to the normal. But they ask us to assume there are 4 values. Then MS has 4 values. Like, how do you get that? Let's say plus 1 plus half, minus 1 minus half, like that. This is as an example. Then for a given orbital, how many electrons are there? I can have it like this. Let's say up 1, down 1, and this side 1 and the other side 1. 4 electrons. There is no rule like this, but this is the only way we can arrange them. There are 4 electrons. Then I assume one up, the other down, other from left to right, other from right to left orientations. Then there are 4 electrons within the orbital. One orbital, there are 4 electrons. That's the special thing. Okay, then we have to answer this. How many electrons could an orbital hold? Then that's very clear. Earlier, one orbital up and down, only 2 electrons. But now you get up, down, left, right. There are 4 electrons. Therefore, answer for the part A, there are 4 electrons. One orbital can have 4 electrons. B, they ask how many elements would be contained in the first and second periods of the periodic table. Then look at this first period. This is the first period. Now, according to normal condition, there are only 2 electrons. 1 S. In the first period, I told you, the period is given by the principal quantum number. N equals 1 means first period. First period can have only one sub-energy level, 1s. 1s sub-energy level can have only one orbital, it's 1s. One orbital. Now, earlier, there can be only 2 electrons, mean there can be only 2 atomic numbers, means 2 elements. 2 electrons mean 2 protons mean 2 atomic numbers, 2 atomic numbers mean 2 elements. You got it, ne? But now, when you consider this orbital, there are 4 possible electrons. There are 4 possible electrons mean 4 possible protons, different number of protons, then 4 possible atomic numbers. Then 4 possible atomic numbers mean there are 4 elements in the first period. So answer for the B, Part B should be 4. I mean, first period, but they are second period also. First period and second period. For the first period, it's 4. And then for the second period, how many? Can you get it? In the second period, normally there are 8. Second period, normally there are 8. Why? Look at this one. Second period mean n equals 2. N equals 2, then you have 2s sub-energy level and 2p sub-energy level. This has only one orbital, 2s orbital. But this has 3 orbitals. You can see it. Yes. 3 orbitals, 2px, 2py, and 2pz. Those are the 3 orbitals we have. Now, earlier orbital can have 2, but now orbital can have 4. Whether one orbital mean there are 4 different electrons, number of electrons, 4 different number of protons, 4 different atomic numbers. Here again 4, here again 4, here again 4. Then in the case of these 3, there are total 4 plus 4 plus 4, 8. Then 4 plus 4 plus 4, 12. 12. So 12 electrons and 4 and 16. Total there are 16 electrons, 16 spin quantum numbers. 16 spin quantum numbers means 16 electrons, 16 protons, 16 atomic numbers. Yes. Instead of 8 elements, there should be 16 elements. There can be 16 elements in the second period. That's what they ask. Then 4 and 16. C, part C. How many elements would be contained in the first transition metal series? First transition metal series means this one, in the case of D block, 3D series is considered as first transition metal series. But in the case of 3D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10. You remember that one. In the case of first transition series, 10 elements are there. Because in first transition series, what we consider 3D. This is what we have, 3D. In first transition series, 3D. But in the case of 3D, you get only 5 orbitals. Earlier 2 only. Then 2 into 5, there are 10 elements only. But now, what is it? There are 4 possibilities. There are 5 orbitals, 1 orbital, 4 possibilities. Then 4 into 5, there are 20. There can be 20 transition elements. Within the first transition series, there can be 20 elements. They are total elements, so therefore we get it like this. 20 elements are possible in the case of 3D. I hope you're understanding this. These questions are given to understand the concept further, right? To check whether you have understood this properly. To develop your confidence in this section, they have changed the question in this manner. D. How many electrons would the set of 4f orbital be able to hold? Then how many electrons would the set of 4f orbital be hold? 4f, you know that story. 4f mean it is 0, 1, 2, 3. F orbital L equals 3. L equals 3 mean there are 7 ml values. So 7 ml values mean 7 orbitals. 7 orbitals into 4, 28. There can be 28 electrons in the F. There's F orbital. Yes. How many electrons would the set of 4f orbitals be able to hold? Set, not one orbital. If it is one orbital, whether it is SPD, there are 4, according to this. But they are set of 4f orbital. Set mean 4. So I mean 7f orbital. 7 into 4, there are 28 electrons. Therefore, answer for the second part D, second question D, should be 28. Okay, let's move to question number 3. In the case of question number 3, you are given several elements in several groups and periods. Part of the periodic table is shown below. You have the tute, I think. But the thing is this one. In the case of third question, I told you, we can't answer the question for most of questions. Why? Because it is not only atomic structure. This is combined with bonding sometimes. This is combined with inorganic chemistry. So we have not done this inorganic chemistry part and everything. Therefore, I ask you not to answer these questions. But In the case of first one, we can answer A has the lowest first ionization energy. Third question, first one can be done, but not all question. They ask the lowest first ionization energy. I think you remember the order. I mean, you see, this is the periodic table. From here to here, ionization energy generally increases. From here to here, ionization energy generally decreases. That's what I told you. Left to right, ionization increases. Top to bottom decreases generally. But this has some up and down, zigzag. Then they ask the lowest. Lowest mean where do you find it? I mean, leftmost or rightmost? According to this variation, left to right increases. The lowest one should be found in leftmost. And top or bottom, down the group, ionization energy decreases. Definitely it should be the down. It should be leftmost down element should be the answer. So the leftmost down element in the given portion, it is CCl. So first one we can answer CCl. Can you answer the second one? Has the highest? Yes, of course. B also can be answered. Then what about the highest one? Then highest one should be rightmost top. Next. Rightmost top should be the highest one. So which one is rightmost top? Rightmost top, it's given neon. So the second part, neon, we can answer it. Thereafter, they ask, has a hydride that forms the strongest intermolecular hydrogen bond? It should be fluorine. Then has a nitrate of formula that evolves brown gas. It can be like magnesium nitrate, magnesium. Can undergo reduction of the type, this one, XO2 plus H plus electron. I thought XO2 plus mean minus 2 into 2 minus 4. And to the other side, then plus 4 plus 5. It can be plus 5 mean like vanadium. VO2 plus vanadium. Has a monopositive ion which forms a complex with ammonia. Monopositive ion which forms complex with ammonia, like what? Silver. Silver has monopositive ion and it can form complex with ammonia. Has a trifluoride with molecule of trigonal shape. And in the class we have completed the shape of molecule, I think. Has a trifluoride with the molecule trigonal shape. Trifluoride trigonal shape. Here I don't discuss in detail because it will be in the bonding part. Bonding homework discussion, I will do that one in detail. Trifluoride mean three, and it has a trigonal shape. Trigonal shape mean maybe this trigonal planar or trigonal pyramid. That's the question. So boron, aluminium, trigonal planar, trigonal pyramid, we can have nitrogen, phosphorus. It's not clear. Maybe trigonal they prefer than trigonal pyramid, maybe. Then nitrogen, phosphorus. Has an oxide used in ceramic and glasses. Then silica. Silicon is available. Yes. Is likely to have the most exothermic reaction with fluorine per mole of X. Is likely to have the most exothermic reaction with fluorine. Then maybe cesium. With fluorine, most exothermic mean highly favorable one. That means most reactive one, cesium. No need to know these things, inorganic bonding, that is where we have it. Has an insoluble chloride. Insoluble chloride. In the case of chloride, yeah, silver, insoluble. Right? But this is enough. If you can answer these first two parts, that's enough at this level. All right, let's move to fourth question. Fourth question, arrange the following groups of atoms in order of increase in size. The increase in size, if you take the periodic table like this, to this side, the atomic radius or size decreases. Down the group, atomic radius increases. That's how atomic radius varies. But now elements given, tellurium, sulfur, selenium. I think you need the periodic table also to understand this. If you have the periodic table, we can easily get the order. Let's see whether I have a periodic table here to be shared. All right, I found a table. Let's see whether you can see it clearly. Right, first sulfur, selenium, tellurium. So where you find them? Sulfur, selenium, and tellurium. I take white color. sulfur here, selenium is here, tellurium is here. It's very clear. Down the group, the size should increase. Down the group, size should increase. So got a sulfur to tellurium, it should increase. In the case of A, it should be sulfur, selenium, and tellurium. Easy. Next one, B, potassium, bromine, nickel. Potassium, bromine, nickel. Where do you find potassium, bromine, nickel? I find potassium somewhere here. This is where you find potassium. Potassium, bromine, nickel. It is nickel here. And bromine here. Can you see that? It's not clear. Maybe clear. No? Sorry. Then left to right, size decreases. The potassium to bromine, the size decreases. Left to right, it decreases. Left to right, it decreases. So when you have the increase in order, it will be bromine. They ask to a term of increase in size. Yes, bromine, nickel, and potassium. Then part C. In the case of part C, what we have, barium, silicon, fluorine. Where do you find barium, silicon, fluorine? Barium. This is barium. Silicon. This is silicon. And fluorine. It is here. Then how do we get it? It is easy, I think, to get it because once you go from here to here, size decreases. Right? From here to here, size decreases. Size decreases. The fluorine, according to that, fluorine should be the smallest one. But there is down the group. I write it here. Down the group, size increases. Again, according to that, fluorine should be the smallest one because it is at the top. Thereafter, it should be silicon and largest one should be barium. Barium in the left-hand side and bottom. Left-hand side bottom should be largest one. Barium largest, fluorine smallest. That's what fluorine, silicon, barium. That's the order. Fluorine, silicon, barium. Doesn't matter, they are in different places, but according to general trend, we can easily find them out. What is next one? Rubidium, sodium, beryllium. Rubidium, sodium, beryllium. If I go back to the periodic table, then it is easy. Rubidium. Where do you find rubidium? Rubidium we found in rubidium. This is where you get rubidium. And next you have sodium. Sodium, where do you find sodium? Here. The sodium should be smaller than rubidium. Down the group increase. And beryllium also. Beryllium this side and top. Rightmost top one should be the smallest one. Rightmost top one should be the smallest one. Beryllium smallest. And then leftmost bottom should be the largest. So the rubidium largest. Beryllium, sodium, rubidium. Beryllium, sodium, rubidium. That's the order. Beryllium, sodium, rubidium. Let's go to E. E given strontium, selenium, neon. Strontium, selenium, neon. If we go back to again periodic table, strontium. We find a strontium here. Strontium, selenium, selenium somewhere here. Here. And neon. Hurry. Then again, go to the normal trend. That's the easiest one. From left to right, what happened? Left to right, size decreases. Rightmost one should be the smallest, mean neon. And down the group, size increases. That. Down the group, size increases. Smallest one should be rightmost top, means neon smallest. The largest one should be leftmost bottom, means strontium. Again, neon, selenium, strontium. Neon, selenium, strontium. Neon, selenium, strontium. Easy. And last one, if given iron, phosphorus, and oxygen. Let's go for the position. We meet iron here. What else? Iron, phosphorus, oxygen. The phosphorus is found here. Oxygen is here. Again, easy. Lowest one should be rightmost top. Largest one should be leftmost bottom. Oxygen, phosphorus, iron. That's the order. Oxygen, phosphorus, iron. That is the increasing order of sizes of these atoms. Get the normal trend. That's the easiest one. Hurry. Fifth one. In each of the following set, which atom or ion has the smallest ionization energy? Now, in the case of question number 5, they asked to compare ionization energy smallest. Calcium, strontium, barium. Again, if you go to the periodic table, with the periodic table, it is quite easy to think about it. What is it? It's about first one, calcium, strontium, barium. First, you should know the trend. What is the trend? Ionization energy. So in the case of ionization energy, you know, down the group, ionization energy decreases. From left to right, ionization energy generally increases. There are some exceptions. That's the order we have. Then let's talk about the element. Calcium, strontium, barium. Calcium, strontium, barium. Now we need the smallest. Smallest one should be bottom one. You see, down the group decreases mean bottom one. Bottom one is barium. In this case, answer for the first part should be barium. What about part B? Part B, they have given potassium, manganese, gallium. Potassium, manganese, gallium. Now different places, not in the same group. Potassium, we see it here. Potassium, manganese, and gallium. Easy. They ask the lowest. Which one is lowest? You know, from left to right, it increases generally. I gave you the order. From left to right, it increases generally. The lowest should be the leftmost one. Leftmost one should be the lowest, potassium. They asked to identify the lowest, not the order, just potassium is there. But if you go to the other potassium, thereafter gallium, manganese has quite larger one. I told you from left to right, it increases. Manganese here, gallium here. Rightmost one should be the largest one. But in this case, manganese larger than gallium. Why? Because manganese has a stable configuration. If you write the configuration, you will see manganese 25. So it has 3d5 and 4s2. You start removing electron from 4s2, stable configuration, difficult. But in gallium, it has ns2 np1, group 13. So we remove electron from p1. It's not stable. But they ask lowest mean potassium. If you get the order potassium, gallium, manganese. Manganese has the highest. Right? C, it's nitrogen, oxygen, fluorine. Remember that nitrogen, oxygen, fluorine. Actually, the other thing, in the case of first ionization energy variation, then I ask you to memorize the ionization energy of the first 20. That's very easy. In most of the case, we need it. You will see, I'll show you the past paper question discussion also. In that case, I'll show you this arrangement is really easy. I mean, if you remember this order, that will be quite easy. Right? It's like this. From hydrogen to calcium. Where do you place oxygen? What we have, nitrogen, oxygen, fluorine. The nitrogen here, oxygen here, fluorine here. The fluorine should be slightly higher than nitrogen. Right? Then they ask the lowest. According to that, it should be oxygen. They ask lowest. Oxygen lowest. What else we have next? Then you have not elements, not atoms. You are given atoms and ions together. Sulfur, sulfide, I mean S-2, S+2 also. In this case, how do we get it? Then look at this one. There is something like this. Ionization energy inversely proportional to the size. When the size increases, electron goes away from the nucleus. When the electron goes away from the nucleus, the attraction is very weak. If the attraction is weak, You have to supply less energy to remove that electron, break that weak attraction and remove that electron. So the size increases, ionization energy decreases. Then once you compare S minus 2, S and S plus 2, we can easily compare the sizes first. What's the size? Sulfur is the atom, parent atom. S minus 2 is the anion. S plus 2 is the cation. I hope you remember in the case of theory classes, I told you, cation is always smaller than parent atom. Anion is always larger than the parent atom. Cation is smaller than atom. Anion is larger than atom. Then this is the order for the sizes. Sorry. Then what will be the ionization energy? It should be opposite. Size increase, ionization energy decrease. H plus 2 has the largest ionization energy. Smallest ionization energy found is minus 2. They ask the smallest. For D, answer should be S minus 2. So if you are given these type of phases, this is the way we get it. Last one, cesium, germanium, argon. Cesium, germanium, argon. We have to go to the periodic table and see it. Cesium, germanium, argon. Where do you find cesium group 1 somewhere here. Germanium somewhere here. Argon somewhere here. Those are the 3 places you have these elements in periodic table. But again, they ask the lowest, smallest. Smallest mean then leftmost bottom one should be the smallest. According to the general variations, we can say it's leftmost bottom. What is it? Cesium. Leftmost bottom should be cesium. Part E, it should be cesium. Question number 5. This is how we can answer regarding ionization energy. Sixth one. Let's go to question number 6. In each case of the following sets, which atom or ion has the smallest radius? Again, they ask about the size. Let's go to question number 6. Again, they compare size. Hydrogen, helium. Hydrogen here, helium here. No need to go to periodic table. From left to right, what happened? Size decreases. So they ask which atom or ion has the smallest one. Helium should be the smallest one. It's easy. From left to right, it decreases. Then smallest one should be the rightmost one, rightmost top one. Chlorine, indium, selenium. Chlorine, indium, selenium. Let's go to that periodic table. Chlorine, it's here. Selenium, it's here. And indium, where is it? Indium, it's here. These are the 3 places you can have. But they are the smallest I told you. Left to right size, what happened? Decreases. Left to right size decreases. The top to bottom size increases. Top to bottom size increases. Then smallest one, where you find it should be rightmost. Left to right decrease mean rightmost. And rightmost top one should be the smallest one. So what is rightmost top one? Chlorine. Chlorine should be the smallest one in this case. You see, it doesn't matter the elements given in different places in the periodic table. Just get the normal trend, then you will find it. Then C given 1120, 1119, 1117. What is this? It is not clear, but I think you can understand it. This is 120, 190, 170. These atomic numbers. But the thing is, we don't have 119, 120 yet. Maybe in future, this can happen. Right? In the periodic table, you see the last one, OG, again, see, 118. Before that, you have 117. This is last one, group 18. Group 18, last one. Then definitely the 119 should come to group 1, but next period. This is where you have 119. This is where you have 120. What are the places in these 3? 117 here, 119 here, 120 here. They asked to compare 119, 20. This here, in between this one and this one, we have large number of groups. The distance is large. 117, 119, 120. Then again, they ask the smallest one. The smallest one should be, I told you, rightmost. Top one should be the smallest one. So which one, rightmost top one? Rightmost top one is, out of these three, 117. The element having atomic number 117 should be the smallest element. I hope you got it. In between these, this is group 1, this is group 2. Hurry. This is group 2. But what is this? This is group 18, this is group 17. So the in between 120 and 117, there is a large gap. Difference is there. So the definitely size should decrease. And when you move up again, size decreases. Therefore, it's very clear. 117 should be the smallest atom. Next, D, niobium. D part here, it's given niobium. Zinc and silicon. Again, go back to the periodic table and see it. Where is NB, NB, NB? NB. This is where you get NB. Next one, zinc. Where is it? Is here. And next one, silicon. It is here. Again, easy. They are the smallest size. So, rightmost top. Rightmost top, you find the silicon. So, D, the answer should be silicon. A, B, C, D, E also available. In the case of E, you are given minus, plus, then this one. They ask directly the sizes. Easy. Then because I told you, anion larger than the parent atom, cation smaller than the parent atom. This should be the smallest one, means the cation, sodium plus. That's how we get the answers for the question number 6. All right, let's move to question number 7 now. Question number 7, I think you understood the question. What you are given actually, for each of the following pairs of elements, for each of the following pairs of elements, pick the one with the more electronegative, more negative electron affinity, the higher ionization energy, and the larger the size. Sorry. Let's keep it like this. A, out of carbon and nitrogen. Carbon and nitrogen. What is it? Next, out of argon and bromine. Argon and bromine. What is it? Next, out of magnesium and potassium. What's it? Then out of fluorine, chlorine. What's it? That's what they ask. For each and every pair, you need one answer. Hurry. First one, the more negative electron affinity. Here you have to be careful. They ask electron affinity. You know what we know, electron gain energy. But what they ask, electron affinity. You know, electron affinity is what? Electron affinity is minus electron gain energy. Minus electron gain energy. Correct? Under the electron gain energy, we discussed so many special points. You remember that one. But now they ask more negative electron affinity. Electron affinity can be negative if you have positive electron gain energy. If there is positive electron gain energy, there can be negative electron affinity. Where do you find positive electron gain energy? You know, electron gain energy can be positive. I told you these things in theory. Group 2 beryllium magnesium can be positive. Group 15 nitrogen can be positive. And group 18, all group 18, like helium, neon, argon can be positive. These are positive electron. This is where we get positive electron gain energy. And beryllium, yes, I put magnesium, I put nitrogen, yes. And group 18 can be positive. Then these elements can have negative electron affinity. Because if electron gain energy positive, electron affinity can be negative. That's what they ask. Hurry. What about carbon, nitrogen? Then out of carbon, nitrogen, nitrogen positive, electron gain energy positive. So electron affinity should be negative. So your answer should be nitrogen. Out of argon, bromine, you know, argon group 18. Group 18 has positive electron gain energy, then negative electron affinity. Magnesium, potassium. You see, magnesium has positive electron gain energy, then negative electron affinity. But out of fluorine, chlorine. Out of fluorine, chlorine, again, it was quite a special. Both fluorine and chlorine have then what? Negative. You remember the value? I think minus 328. I'm talking about electron gain energy. Electron gain energy minus 328. This is minus 346 or something, 609. Like this. These are negative electron gain energy. Then what will be electron affinities? Minus 328 means same value but plus. Minus 349 means same value plus. These are electron affinities. We get two positive values, but they are more negative one. More negative, but both positive. Then less positive can be more negative. We can say like that. Fluorine. Out of fluorine, chlorine, more negative electron affinity is found in fluorine. I think you notice it, Hari. They don't ask electron gain energy, they ask electron affinity. And again, in electron affinity, they ask the more negative electron affinities. I think you got it. These things should be the answer for the first set. Hari. B, what is B? B is about the higher ionization energies. Hari. If you consider higher ionization energies, then out of carbon, nitrogen, it should be nitrogen. Why? Nitrogen has a stable configuration, partial. Argon, bromine, it should be argon. Why? Argon has complete stabilization. Out of potassium, magnesium, which one is that? In the periodic table, you find potassium here, and sodium here, then magnesium here. This has small size and S2 configuration, NS2 stable configuration. Potassium has NS1 configuration. So if you get stable configuration, magnesium should be large. Or in the other case, you have that ionization order, first 20 elements order. Within first 20, you meet these two. You will see magnesium larger than potassium. They are larger in a higher ionization. Yes, magnesium. Out of fluorine, chlorine, both fluorine, chlorine found in the same group. Down the group, it decreases ionization energy. Fluorine should be the larger ionization energy. See the larger sizes. Then I told you the size. What happened to size? Carbon, nitrogen, carbon 14, nitrogen here, either from left to right decreases. They are larger size, either it should be carbon. Argon, bromine, again left to right decreases. Larger size mean bromine. Magnesium, potassium. You see magnesium, potassium, two different periods, two different groups. In that case, small one should be rightmost top. I told you. Then they are larger. Leftmost bottom one is potassium. That way easy. That way easy to compare it. Thereafter, fluorine, chlorine, down the group increases. Then chlorine should be the larger one. This is the way we answer question number 7. I hope you're okay with this one. All right, let's move to 8th one. In 8th one, they ask, then you have to mark it, true or false. All right. State whether each of the following is true or false. First one, modern periodic law is based on atomic masses of element. False. We arrange elements according to the atomic numbers, not the masses. In the previous groups, before the periodic table, we had several classifications like Dobereiner's triad, Lothmeyer's octaves, Mendeleev periodic table. In all the cases, we arrange them according to mass numbers. But now, in modern periodic table, it's atomic number, therefore it is false. First part, it's false. B. If elements are known as lanthanides. If elements are known as lanthanide, no. Lanthanide is one type of F elements. Other than that, we have actinide also. Actinide also, therefore, if elements are known as lanthanide, no. That's false. Lanthanide is one example, one type of F block elements. F minus ion has a smaller size than F atoms. No, in that case, I told you, anion is always larger than the parent atom, not smaller. Among isoelectronic species, sodium plus, Mg2 plus, aluminum 3 plus, yes, we know then all of them have 10 electrons. Species having same number of electrons should be isoelectronic. The ion having smallest radius is aluminum. I told you for isoelectronic species, there is a way. For isoelectronic species, radius is inversely proportional to number of protons. Number of proton increases, the radius decreases, because you know why. Number of proton increases, positive charge of the nucleus increase. Positive charge of the nucleus increase means the electrons then attracted, pulled by the nucleus is stronger, then the electron cloud shrink, size decrease. So the proton increase, size decrease. Then which one out of these have in largest number of protons? Sodium 11, magnesium 12, aluminum 13. Aluminum should have the smallest one. That's what they say. Yes, it's true. According to this theory. A, B, C, D. Then we have E statement. Let's see that one. The ionization energy of nitrogen atom is smaller than oxygen. No. You have that variation. You see nitrogen larger because nitrogen has partial stabilization. Not the radius here, the predominant one configuration. According to that, it should be nitrogen, not the nitrogen larger, not smaller. Therefore, it's false. If electronegativity is the property of an isolated atom, no. How to define electronegativity? The ability to pull the bonding electron, attract bonding electron. Bonding electron means the atom should be already bonded with something. It's not isolated. It's bonded with something means there should be another atom. Therefore, we define electronegativity with respect to the other atom in the bond. It's not isolated property. It's false. G, electronegativity and electron affinity represents the same property of an atom. It's completely false. Because electronegativity is the ability to pull the bonding electrons. Electron affinity means something else. You know, electron gain energy ability, the electron gain energy is this one. Energy change when gaseous atom gain electron from outside, not the bonding electron. Because electron affinity should be the opposite. Uninative gaseous ion remove electron to form gaseous atom. That's electron affinity. They ask electron affinity. That one and electronegativity completely different. It's not same. FGH. What about H? Electron affinity of fluorine greater than that of chlorine. No. You know, remember this one. Electron gain energy variation and electron affinity variations are same. Electron gain energy is not same as electron affinity. You know, electron affinity minus electron gain energy, but the trend is same. I explained the theories from left to right, the electron gain energy increases. From top to bottom, electron gain energy decreases. That's a general one. But there were several exceptions. We discussed each and every exception, you remember. One exception is fluorine, chlorine. So down the group, it should decrease. But chlorine, I told you, larger than the chlorine. Third period elements larger than the second period elements in most of groups, except group 1, all the other. Third period element greater than second period. That is electron gain energy. But the variation of electron affinity also same pattern. So chlorine should be larger than fluorine. But this says what? Electron affinity of fluorine greater. No, it's not. Chlorine greater. All right. A, B, C, D, F, H, I. In the case of I, what do we have? The electronegativity of fluorine is 4.0. Yes, according to Linus Pauling, it's 4. That's the highest. J, third period of periodic table contain 18 elements because third quantum shell includes 3s, 3p, 3d orbital. Third period of periodic table contain 18 elements. Third period start from sodium. Let's see. We have the periodic table. Let's look at it. Third period. What is third period? This one is the first period, second period, third period. Third period, how many? 2 and 6. There are only 8 elements. False. J, then K. K, the electron configuration of group 5, NS2, NP5, it's false. NH2 NP5 for group not 15 actually. It's group 17. 2 plus 5. I told you. In the case of P, we had 2 and 5, it's 7, but we had 10 finally 17. So group 17, not group 5. Group 5, it should be D3S2. D block. It's false then. K, it should be L next. Hurry. What is it? L. Periodic table includes more metalloids than non-metals. False. Metalloids, the number is very small. Majority metal, left-hand side, nearly two-thirds of elements are metals. Thereafter, right-hand side, you have non-metals. In between metal, non-metal, you have metalloids. But that number very small, like 6, 7, 5, 6, 7, metalloids. But they say metalloid larger than non-metal, it's completely false. L. M. In the case of M, we get electronegativity of an element depends upon its atomic size. Electronegativity of an element. Yes. Electronegativity inversely proportional to atomic size. I told you. Yes, it's true. M, next N. The element having electronic configuration NS2, NP6 are known as chalcogens. No. NS2, NP6 mean group 18. 2 plus 6, 8 and 10, 18. So group 18, we take like noble gases. Noble gases. Chalcogens means what? Group 16 elements. They are NS2, NP4. NS2, NP4, 16. Those are chalcogens. Right? Not group 18. O. Element O. What is this? The electron affinity values of alkaline earth metals greater than those of alkali metals. Remember, electron affinity means negative electron gain energy. I think, yeah. Then what about the electron gain energies? Group alkali metal mean group 1. Group 1 negative. Alkaline earth metal mean group 2 positive, generally. In the case of electron gain energy, we put minus values like the greater one. If someone say minus 50 and plus 50, in electron gain energy, we identify minus 50 as the higher electron gain energy. So in the case of electron affinity, it should be then same order. I mean, then minus 50 becomes then plus 50 in the case of electron affinities. Plus 50 becomes then minus 50 in the case of electron affinities. Then plus 50, in the case of electron affinity, plus 50 is taken as then larger electron affinities. I told you then trends in electron gain energy and the electron affinities are same. But if you compare two things and find one has larger electron gain energy, then remember that one has higher electron affinity also. So group 1 has larger electron gain energy out of group 1, group 2. Then group 1 has larger electron affinity also. Is that given here? Electron affinity value of alkaline earth metal mean group 2 greater. No, it's false. Alkali metal should be greater. Next, P. Half of the transition elements are metals and other are non-metals. No, those are transition metals mean those are, D, all are metals. So that is false, not half. All are metals. Q. Amongst metals, alkali metals have lowest ionization energy. Ionization energy increases from left to right. The leftmost one should be the lowest one. Increase from left to right mean lowest one should be leftmost. Yes, leftmost mean alkali metals. That's true. Q, then R. Group 13, the first member is metalloid and the rest are metals. Actually, these things you learn in P block, inorganic chemistry. First member group 13, boron. Boron is metalloid, yes. And the rest are metal, yes. It's true statement, but you learn that one in inorganic. Okay? R, then S, all halogens are non-metal. All halogens are non-metal, that's also true. Halogens are found in the rightmost side. Group 17. Before group 18, you have 17. The rightmost, it's non-metals, yes. P, the Last one, T. The second ionization energy of sodium is greater than that of magnesium. Look at the first ionization energy. It's this way. If I just take it like this, before sodium we have neon, then neon first ionization here, then sodium here, first ionization, then magnesium here. But if you want to compare, this is first ionization. If you want to compare second ionization energy, I ask you to shift this element to left hand side by one place. So if I want to find out the second of sodium, the first of sodium here means second of sodium should be placed here. First of magnesium here means second of magnesium should be placed here. And then, yes, second of sodium greater than magnesium. Is that they have given? Second of sodium greater. Yes, second of sodium. Second means here, red color. You can see it. Ne? Sodium is greater than magnesium. That's true. These are easy way. There is a logic. The logic is this one. Once you remove electron from 3s1, you have 2p6. Complete stable configuration. Second electron is removed from complete stable configuration and second energy level. But in the case of magnesium, it's 3s2. Once you remove one electron, it becomes 3s1. The 3s1 is not a stable one, and it is from the third energy level, weakly bound. So therefore, Mg should be lower than sodium. Right. That's how we get the answers for question number 8. True and false statement part. Okay. Question number 9. Complete the following by inserting appropriate answers. So this is quite then confusing maybe for someone. Lanthanides are known as space elements and belong to space block. Actually here, D block 3D, I mean, we call them transition metals, but F block metals, we call them inner transition metal. Inner transition. So it says, forget the metal part. Then for the first space, it should be inner transition elements and belong to, lanthanide belong to what? F block. Ne? Part B, they ask sodium plus neon and magnesium 2 plus contain the same number of electrons. Is that? Sodium atomic number 11 plus 1 mean 10 electron, neon 10. Yes, they have, yes. Such species are known as, then, those are isoelectronic species. Isoelectronic species. See, electron gain energy of noble gases is, yes, noble gases group 18. It is positively. D. Most widely used electronegativity scale. It's very famous, Linus Pauling. Linus Pauling. I hope the spellings are correct. A, B, C, D, E. Among group 15, the metalloids are, among group 15, nitrogen, phosphorus, arsenic, antimony, bismuth. There are nitrogen, phosphorus, non-metals. Thereafter, we have arsenic, antimony. These are metalloids. Among group 13, metalloids are, there is a printed mistake, I think. It's given group 13, but the thing is in group 13, we have only one metalloid, barium only. We don't have two metalloids. Therefore, there is a printing mistake there. Cut 13 and write 14. Yes, 14, they have, there are two. Group 14, cut 13, write 14. Among group 14, metalloids are, it should be carbon is non-metal. There are silicon and germanium considered as non-metalloids. There is a printing mistake. You have to change it. G. The vast majority of the alkali metal and alkaline earth metals form which compound with halogens. This is something like, again, inorganic or maybe just bonding part. alkali metal, alkaline metal are electropositive elements, ne? Highly electropositive metals. Halogen mean highly electronegative one. Between electropositive, highly electropositive, highly electronegative, you get, most of the case, you get ionic. Compounds between highly electropositive and highly electronegative, those are ionic. A, B, C, D, E, F, G, H. H, there are elements known in noble gases. Then here, helium, neon, argon, krypton, xenon, radon. These are clearly gases. But last one, this we have organism or organosine. Last one. In the case of last one, it is the heaviest one. Therefore, someone say it can't be gas. But that belongs to noble gases family. Then someone say it is a gas. Therefore, in that case, there is a problem. Confusion is there. Organism, yes. Organism. So then there is a confusion here. It's not confirmed. Therefore, we can say 6 or 7. Then we are safe. Except OG, all the others are noble gases, but OG has a problem. Let's say 6 and 7, 6 or 7, like that. Except these two other noble gases are totally inert. Actually, in the case of noble gases, most of them are inert, but except krypton and xenon. Why? It's krypton and xenon. They have large atomic radius. The valence shell electrons are then maybe then helium 1, neon 2, helium, neon, argon, krypton. There are 4s2, 4p6. There are 4p6. We have 4d also in the krypton. Then xenon has 5s2, 5p6, then 5d also there. Between 5p, 5d, the energy difference is very small. So there can be some kind of excitation. We have not done this one in hybridization part, will be discussed under bonding. Then you will understand that part. Then after excitation, we have unpaired electron. We have unpaired electron mean ready to combine with some other and make the chemical bond. Therefore, krypton, xenon, they can make some compounds up to certain extent. Out of that, xenon is the famous one, very famous one. J, I put it here, no space. J, the second ionization energy is always than first ionization. Then in the case of successive ionization energies, we discuss it. Successive ionization energy is increasing. The second should be greater than first. It is greater. Second is always greater than first one. Correct? That is J. And question number 9. Let's move to 10. Question number 10, again, several elements given in several different parts. Calcium is there. That group should be definitely group 2. Before that, group 1. Likewise, we can, I hope you have the table. It's calcium given. From calcium, we identify group 1. Just before that, group 2. Just before that, you have group 1. Correct. Using the above abbreviated periodic table, answer the following questions. First one, most electronegative. For electronegativity, what happened? Left to right increases. So once you get the periodic table, from here to here, electronegativity increases. From here to here, electronegativity decreases. They ask most electronegative. Whether most electronegative should be rightmost top. Rightmost top, except noble gas. E, the last group in noble gases. Then except noble gases, we come to the other. Then C. Except T, rightmost top one is C. So most appropriate answer for this one should be C. Because noble gases do not make chemical bonds, except krypton and xenon. They don't make chemical bond mean we can't define electronegativity, because electronegativity is the ability to pull the bond in electrons. B, the element with a possible oxidation number -2. Then again, this is something in chemical calculation, last part. Oxidation state I will discuss. Then group 18 mean E group 18, then 17 C group 16, group 16, then can have -2 like oxygen, then C, but forget it. Element that would react in 1-to-1 ratio, again, then video, I mean the inorganic chemistry, just forget it. Then element that would react with 1-to-1, then the like it's B. React with deuterium 1:1, but no, not B. It's calcium. Not A. A doesn't react with deuterium, then calcium. Those things actually then in inorganic chemistry. The element with the smallest ionic, then ionic radius. Elements with the smallest ionic radius. C, then calcium can be. Then D, the element with the smallest ionic. Smallest ionic. So whatever it is, ionic, maybe whatever it is, then from left to right, radius decrease. Atomic radius or ionic radius decrease. Top to bottom, atomic ionic increases. That's the way. So they ask the smallest ionic radius. Smallest should be rightmost top. Rightmost top. But in this case, we have to be careful with the type of ions, whether it is positive or negative. The rightmost E cancel because it doesn't make ions. Then rightmost top should be the smallest, I said, C, oxygen. But oxygen forms -2. The minus means, what about that? Minus mean electrons added. The size of the electron cloud increase, then negatives are larger. I mean, the anions are larger. But then look at the calcium part. Calcium makes then +2. So if calcium makes +2, it has then smaller size. But the thing is, wait a minute, if this is calcium, C is not oxygen. It should be sulfur. Because calcium means the potassium, hydrogen, sodium, potassium, rubidium. Yes, for the third period. AC should be in the second period. Second period, wait a minute. Beryllium, magnesium, calcium. Wait a minute. Calcium fourth period. Calcium fourth period mean just before that, just above that should be third period. The third period, group 16, C is sulfur. Most electronegative element, sulfur, it's still okay out of the others, yes. B, element with possible oxidation, yes, sulfur can show -2. C, then no sulfur. Yeah, C is sulfur. So S -2. S -2, then anion, then large, 18 electrons, Calcium 2 plus, cation small, there are 18 electrons. Isoelectronic, S -2 and Ca2 plus isoelectronic. 18 electron, 18 electron. For isoelectronic, I told you size decrease when the number of proton increase. Size decrease when the number of proton increase. I gave it somewhere. Because of that, they ask the smallest ionic means it should be again calcium. Although we have this trend, but we have to be careful with the type, whether it is anions or cations. If it is anion only, then ionic radius decrease. If it is cation only, ionic radius decrease. Correct? But if it is anion cation, then we have to be careful. So I hope you understood it. Calcium has the smallest because it's a cation. Right. Then C, the element with the smallest first ionization potential, E. So ionization energy, ionization energy generally increase from left to right, decrease from top to bottom. They ask smallest first. Should be leftmost bottom. Which one is leftmost bottom? The leftmost B. B can be. Leftmost bottom, it's B. A, B, C, D, E, B. Then F. If the question, the element with the complete p orbital and its outermost energy level, and as it's also a complete p means p6, verified p6. P6 found in group 18, NH2 NP6, group 18. Group 18 elements E. G, a member of alkali metal family. Alkali metal means the group 1. Group 1 member being A, B, C, D, E, F, G, H. A noble gas, group 18, E, I. The element that would react most actively when placed in water to form a strong base in organic chemistry. B. Group 1 elements make hydroxides. Those are very strong bases. It's okay. This is inorganic. Okay? That's about then question number 10. We have one more question under the developed confidence. Means before we move to past papers, we have one more question. So what's that? It is this. Let's go to 11th one. Refer the periodic group shown as they are aligned. It's given halogen group, means group 17. Fluorine, chlorine, bromine, iodine. Element that most reactive chemically. Again, you can't understand it. But once you consider this fluorine, chlorine, bromine, iodine, those are halogen group given 1, 2, 3, 4, 5. Fluorine, chlorine, bromine, iodine, astatine. Remember, halogens react by gaining electron. If you don't understand this, it's okay. It's not atomic structure. Gaining electron is easy in the case of fluorine, small size. Therefore, the most reactive one in inorganic chemistry we will learn, it's fluorine. B, element with the smallest ionic radius. Then down the group, whatever it is, radius increases. Smallest ionic radius should be again fluorine, ABC. I take the actual symbols because halogen group given, you can go to the periodic table and see the actual symbol. The element with the lowest first ionization energy. So down the group ionization energy decreases. So the lowest should be astatine. They consider only 5 elements, 1, 2, 3, 4, 5. Means you end up with astatine here. And the element that first shows some metallic properties at the room temperature, then going down the group, metallic nature increase. Down the group, size increase. The size increase means ability to remove electron increase because ionization energy decrease. The metals, the nature is loose in electron. The bottom one has very high chance to be metal. So the bottom one is astatine. Most probably, astatine can be a metal. I mean, there is high chance for astatine to become metal. Larger size, smaller ionization energy, highest ability to release electron, loose electron. Okay. Then I discuss all the questions under develop confidence. Then you have test your confidence part. Past paper questions. Okay, now you have it past paper discussions. Test your confidence. Past papers are given from 2008 to 2021. Because in 22, 23, 24, 25, 24, there was no question from this section given as MCQ. So 2021, let's start with 2021. Decrease in order of the first ionization energy of atoms. Okay, then now you are given 1, 2, 3, 4, 5, 6 atoms given to compare the first ionization energy decrease in order. Then there are some factors, then considered in factors. You can consider, you can get the decrease in order of these 6, but if you go to that way, logical way, it takes long time. Then what I have given here, the easy method, remember the variation of first ionization energies of first 20 elements. That's what I asked you to do. The hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. In that case, I ask you to keep argon slightly higher than nitrogen. Argon slightly higher than nitrogen but lower than fluorine. Slightly higher than nitrogen but lower than fluorine. And hydrogen and oxygen in same level. Approximately, they are same. So when you manage the graph in that manner, then you end up with correct variation. All right. Let's find out the elements. Where do you find the elements? Now you are given hydrogen. Hydrogen is here. Helium here. Hydrogen, helium. Thereafter lithium. Lithium here. Beryllium here. What else? Boron. Then sodium. These are the places. I hope you can see that. Sorry. They ask the decrease in order. Then what about the decrease in order? Started with the highest helium. Thereafter hydrogen. After that beryllium. After that boron. Then lithium. Then sodium. Okay, where you find this? Helium, hydrogen, beryllium, boron, lithium, sodium. It's answer to 2021. Answer to 2020. Decrease in order of the radii of species. It's about the radii. Decrease in order of the radii. 2020. I'm talking about. All right. It's given OO2 minus, FF minus, S2 minus, and Cl minus. Sorry. In the periodic table, you see oxygen here, group number 16. Second period, you have oxygen. Thereafter, group number 17, second period, you have fluorine. Other than that, O minus, F minus 2, sulfur and chloride. Sulfur here, Cl here. Right? Then when you consider these atoms, then we know the size decreases from left to right. Therefore, fluorine smaller than oxygen. That's what we know. But down the group size increase. Down the group size increase. Hurry. Then how do we get it? Next, you are given O2 minus, F minus, S2 minus. You know, they have given O2 minus. What else? F minus. Next, you are given S2 minus and Cl minus. So in O2 minus, F minus, there are 10 electrons. S2 minus, Cl minus, there are 18 electrons. So when you write the configuration, 10 mean 2, 8. 18 mean 2, 8, 8. So this has only 2 energy level. This has 3 energy level. Oh, so if you have 3 energy levels, then that should be larger than this one. You know, this is 1s2, 2s2, 2p6. This is 1s2, 2s2, 2p6, 3s2, 3p6. There are 2p6, 3p6. Definitely, these two should be larger than these two. Next thing we know, anions are larger than the parent atoms that were out of oxygen, fluorine, and O2 minus, F minus, oxide fluoride. Oxide fluoride should be larger than oxygen and fluoride. Got it? They ask decrease in order. Which one is the largest one? Atoms are smaller than an ion. Out of these two sets, this anion should be larger than this one because there are 3 energy levels. But out of these two, which one is larger? In that case, I told you, if it is isoelectronic species, radius decreases when atomic number increases. So atomic number sulfide 16, this is 17. So 17 should be smaller than 16. Atomic number increases, size decreases. So the largest one should be sulfide, thereafter chloride. 3 energy levels, negative ions. Then highest atomic, lowest atomic number. Out of these two, low atomic number. Then size large. Thereafter, next here, anion should be larger than oxygen atoms and fluorine. Therefore, 2 minus, F minus should be larger than OF. But out of this again, atomic number increases, size decreases. That means O2 minus should be larger than F minus. Atomic number increases, size decreases. Thereafter, OF atoms, then size decreases. You know, next oxygen, then fluorine. This one is found in first answer, I think. Yes. So question number A-level 2020, answer should be first one. First compare with the atoms and anions larger, then compare two sets of anions, number of energy level increase, then size increase. Then compare atomic numbers, atomic number increase, size decrease. That's the order. 2019, identify the pair of element which has the largest difference in electronegativities. Sorry, 2019. In 2019, the pair of elements which has the largest difference, it's got boron aluminium, boron aluminium here. Next, beryllium aluminium, it's here. Next, boron silicon, it's here. Boron carbon, it's here. Aluminium carbon. They ask highest electronegativity difference. I think you can understand. From here to here, electronegativity increases. From here to here, electronegativity decreases. Right? Then there's the largest difference. Largest difference. Where do you find largest difference? Largest difference should be found between the least electronegative one and the most electronegative one. Lowest electronegativity and highest electronegativity, that difference should be the largest difference. So where do you find the lowest electronegative one? Rightmost or leftmost? Definitely leftmost. Leftmost, top or bottom? Bottom. Leftmost bottom. And highest one, where do you find? Rightmost top. Can you see that one? In the periodic table, least one here, most one here. Between the least and most, there should be the largest difference. There should be the largest difference. Then in the answers, can you see this type of two elements given? Boron aluminium, you see? Boron aluminium, it's just down, not this, down. Beryllium aluminium, it's this way, this way. It's not this way, but it's this way. Can't be. Boron silicon, then again this way. This way. It can't be. It should be this way. Boron carbon here, it's just this way, not this way. Just same group, same period and different groups. Aluminium carbon. Can you see that one? Once you get aluminium carbon, that is where we have the least one and the most one according to the given elements. Got it? So therefore, between aluminium carbon, this variation, this pattern, this direction is there. That is where you have the highest electronegativity difference. Largest difference in fifth answer, aluminium and carbon. I hope you understood. Otherwise, there is no any other way. We don't remember the values. If there are values, we can get the difference and answer it easily, but we can't remember it. Then this is the logical way to get the answer quickly. Question number, the A-level 2018. 2018, it's given like this. In which list are the element to give the order of increase in atomic radius? Increase in atomic radius. Okay, in that case, then this one, from here to here, atomic radius decreases. From here to here, atomic radius increases. Increase in order, that's what we need. For that, we have to go to the periodic table. It's lithium, sodium, magnesium, sulfur, then lithium, sodium increasing, but sodium, magnesium decreasing. You remember then lithium here, sodium here, magnesium here. So lithium to sodium increasing, yes, but sodium to magnesium decreasing. So magnesium should be smaller than sodium, but in the first answer, magnesium larger than sodium can't be. Second set, carbon, silicon, sulfur, chlorine. Where do you find it? Carbon here, group 14. Silicon here, carbon, silicon, sulfur, chlorine. So sulfur somewhere here, chlorine somewhere here. Group 16 and 17 in the same period, silicon. So then carbon to silicon increasing, yes, but silicon to sulfur, decreasing. Silicon to sulfur decrease. But according to this, sulfur larger than silicon. It can't be. Boron, carbon, nitrogen, phosphorus. So I got boron here, carbon here, nitrogen here, phosphorus here. Boron, carbon, nitrogen, phosphorus. See, it's given boron, carbon increasing. No, boron to carbon decreasing. The carbon should be smaller than boron, but it says boron to carbon mean increasing. No. Fourth one, lithium, sodium, potassium, calcium. I thought lithium, sodium, potassium, calcium. Yes, lithium, sodium, potassium, correct. But potassium to calcium, again decrease. Potassium to calcium decreasing. The calcium should be smaller than potassium, not larger. Fourth one wrong. Then it should be fifth one. You see, boron, beryllium. Beryllium here, boron, beryllium, sodium, potassium. Look at this. Boron to beryllium increasing. Yes, because here decreasing, here increasing. And then beryllium here, I mean the second period, third to fourth, then what happened? Increasing. So sodium to potassium increasing. Yes. Therefore, question number, the A level 2018, the answer should be 5. According to the general trends, we can find it out. 17. 2017. In that question, they say the effective nuclear charge felt by the valence electron in lithium. Lithium atomic number given, what is it? Z3, atomic number 3. If lithium atomic number 3, how do we write the configuration? Atomic number 3 means 2 and 1. So once you find the effective nuclear charge, we have atomic number minus screening effect. Atomic number then 3, then there are plus 3 proton charge in the nucleus. Shielding effect because of the inner electron should be 2. According to that, we get plus 1. Then what about equal to plus 3? No. Less than plus 3? Yes. Plus 1 less than plus 3. Remember this one even less than plus 1. Equation gives the value plus 1. But in the equation, the distance is not considered. So once you consider distance, there is a certain distance between the nucleus and the outer electron in lithium atom. So certain distance you have mean definitely attraction decreases. Okay. But roughly we can say plus 1, then it is less than 3. So answer should be 2. Correct? 2060. Which of the following atom in its gaseous state will liberate the largest amount of energy when it gains electron? That means a gaseous atom is there, it gains electron and becomes uninegative gaseous ion. They ask which one liberates the largest energy. Liberates means what? Release, energy released. If energy release, what is that? Exothermic or endothermic? In all level you learn. Energy release mean, heat release mean exothermic. Exothermic mean negative, minus. I think you identify this one. This is about electron gain energy. Electron gain energy is the energy change when gaseous atom gains electron to form uninegative gaseous ion. They ask most negative. Right? Liberated mean release, release mean negative. Most negative electron gain energy, that's what they ask. Then out of sulfur, phosphorus, sodium, magnesium, neon, where do you find them? If I take the places, sodium here, group 1, thereafter magnesium here, after that neon is here, group 18. After that you get sulfur, phosphorus somewhere here, sulfur somewhere here. So they ask liberates negative, neon positive, magnesium positive. You can easily forget these two. They don't liberate, they absorb. After that, what happened? From here to here, electron gain energy increases. Then according to that, which one is largest? Sulfur should be the largest one. Sulfur is given in first answer. 2016. Thereafter, again, we have 2016 question. Which of the following statement regarding size of ions formed by S and P block element false? Which one is false? Not correct. Cations are always smaller than neutral. Yes, I mentioned it in the previous discussion part. Anions are always larger than neutral. Yes. The size of cation decreases from left to right. I told you then whatever it is. If you consider cation, decreases from left to right. If you consider anion, decreases from left to right. The size of anion increases from left to right. No. Size of anion also decreases. So that is false. Fourth one is false. Fifth one again correct. The size of anion formed by element of the second larger than the cation formed by third. Yes. You can see the cation third. But if I go back to the previous fourth one, then if you consider third period starting from sodium, sodium plus here, magnesium 2 plus here, Aluminium 3 plus here, you see. When you go from left to right, cation size decreases. Right? Then if you go to silicon, even silicon plus 4 further decreases. Once you go to phosphorus, thereafter we have phosphorus sulfate. Then phosphorus don't make plus 5 ions. Then we have mainly phosphorus plus minus 3 ions. Then minus negative ions are larger than the positive ions. But phosphorus, then sulfur, S minus 2. Then chlorine, you see, again anion size decreases. And all these anions are larger than cation. But if you consider cation from left to right, decrease. If you consider anion from left to right, it decrease. Both anion cations decrease. But fourth one say anion increase from left to right. No, wrong. Then the size of anion formed by element in the second period. Second period element I take like fluorine, anion is F minus. Larger than the cation formed by element third period. The third period cation, let's say sodium plus. Then out of these two, look at this, atomic number 9, atomic number 11. Both of these two have 10 electrons, isoelectronic. Then radius is inversely proportional to proton. The proton increase, size decrease. So you see, sodium plus is smaller. In other words, anion formed by second period element larger than cation formed by third period. The fifth one is correct. They ask false statement. False statement should be according to that fourth. Thereafter, we have 2013 question. It's quite easy. 2030. What is that? Highest oxidation state. Oxidation state, again, we will discuss that one under chemical calculation at the end. Therefore, maybe you can't answer this question, but electron configuration can be, they ask chromium. So chromium, atomic number 24. So if I use inert gas core, argon 18, 3p6. Thereafter, we have 4s2. So 18 to 20. There are 24, 4 more. It's 3d4. But I told you, in the case of 3d4 does not exist because it's very close to partial stabilization. Then one of these electrons jump. Because of that, it becomes finally argon, 4s1, and 3d5. That's the electron configuration for chromium. So it is there in two answers, answer 2 and answer 5. But they ask highest oxidation state. In the calculation we will discuss in chromium, all these electrons can be removed. There are 5 and 2, total 6 can be removed. Therefore, it should be plus 6. So this configuration and plus 6. It is fifth answer. If you find difficulty in oxidation state, it's okay. It will be there in chemical calculation part. Don't worry. There is another 2013 question. What's that? First ionization energy order. Again, first ionization energy order. Let's see what are the elements available. It's given nitrogen. I erase these things and take the elements given in this question. Right? Nitrogen here. Thereafter, neon here. Thereafter, sodium here. Thereafter, phosphorus here. Thereafter, argon here. Thereafter, potassium here. What do they ask? They ask the increase in order. Then which one is the bottom? The lowest. Potassium lowest. Thereafter, sodium. After that, it should be phosphorus. After phosphorus, it should be what? Nitrogen or argon. That is why I told you, very important. I told you argon is slightly higher than nitrogen, but lower than fluorine. Before argon, we meet nitrogen. Thereafter, we meet argon, and the highest one should be neon. This is the correct order. Potassium, sodium, phosphorus, nitrogen, argon, neon. Where is it? Fifth one. Correct. This discussion will be quite helpful for the term test you are going to have this week. Not term test, unit test. Now we are in unit 2 and unit 3, chemical bonding, structure and bonding and chemical calculation. We have completed atomic structure. Under atomic structure, I complete the 8 printed notes. That means the complete theory explanation. Thereafter, we did questions during the explanation of theories. Other than that, we did 3 homework sheets. Likewise, we discuss all the question discussions there. Other than that, we had 5 memory locks. That means quizzes, exams, 5. Then we are now have done everything under unit 1. Then only one is remaining. That is the unit test. So you're going to have unit test next week. So this is a kind of preparation for unit test. So therefore, this discussion really important to get some decent marks there. Okay, let's go to 2012. The number of elements that can exist liquid at 25 and 1 atm, that is then answer 2. There are 2, ne? What are these? Bromine and mercury. Even you learn in that one O-level, I think. There is another 2012 question. Increase in order of the atomic radii of carbon, oxygen, aluminium, phosphorus, calcium. Let's see what are the position. Carbon is there. Oxygen is here. Phosphorus below that. Nitrogen here. Then phosphorus below that. Aluminium is also there. It is here. What else? Calcium also there. Calcium should be below that here. And then they ask atomic radii. If you take this as periodic table, then from here to here, atomic radius decrease. From here to here, atomic radius increase. So we start from the lowest. Smallest one should be rightmost top, means oxygen. Largest one should be leftmost bottom, calcium. Oxygen, calcium. Where do you find it? Oxygen, calcium is in first answer and second answer. In first and second, the problem is aluminium, phosphorus. If you consider aluminium, phosphorus, you know, from here to here decrease, mean phosphorus small, aluminium large. So it should be second answer. C, P, and A. Answer 2. In that question, answer is 2. Right? Then we go to another 2012 question is there. Let's erase this and have it. Okay, page number 6. Bottom you have 2012 question again. Which of the following statement is not true with regard to elements in the second period from lithium to fluorine? Highest negative electron affinity is shown by fluorine. What are the elements in second period? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Up to fluorine, ne? Yeah, up to fluorine. Then they ask highest negative electron affinity, you know, beryllium plus, nitrogen plus. Then from here to here, electron gain energy increase. I told you in the case of electron gain energy, electron energy increases mean most negative. Negative value increases. Right? So then shown by fluorine, yes, rightmost one, fluorine, it is true. But they ask false statement. Highest positive electron affinity. Highest positive electron affinity shown by beryllium. And then there is a problem. This is in A-level 2012. 2012, the electron affinity and electron gain energy, they refer them both same. Electron affinity, electron gain energy, same. But now, you know, it's different. Electron affinity is the negative electron gain energy. I mentioned that one. Then they ask highest positive electron affinity. The highest positive electron affinity is the one which has highest negative electron gain energy. Because electron affinity is minus electron gain energy. If there is most negative electron gain energy, that is where you get highest positive electron affinity. The highest positive electron affinity is shown by beryllium, wrong. Highest positive electron affinity again shown by fluorine. Right? Because it has the highest negative electron gain energy. I hope you remember I explained in the previous case. But in 2012, they did not take second one as the correct answer because they refer, I told you, then electron gain energy part as the electron affinity. So the highest positive electron gain energy is found in beryllium. Both are positive, but beryllium has complete stable configuration. Adding electron to that will be very difficult. Means we have to supply more energy. So beryllium is the largest positive electron gain energy. But in 2012, they refer electron gain energy, electron affinity same. The largest positive in beryllium, they have considered it as the correct one. But actually, it's not correct. Now electron affinity is negative electron gain energy. Then it should be fluorine. Right? But I go back to 2012 and refer that then marking scheme. According to that, it is then true statement. The highest oxidation state exhibited by carbon. Then the thing is this on oxidation state. You don't know that one here because it's given in unit 3. We will discuss it later. Then these are the highest oxidation state. Fluorine highest actually +2. Fluorine highest then 0. These are the highest oxidation state. Then they say highest oxidation state exhibited by carbon. No, it's nitrogen. Nitrogen can show +5. Carbon +4. That is the false statement. Then answer given 3. Others are correct. Atomic radii decrease from left to right. Yes. Left to right atomic radius decrease. Yes. Ability to form cation and to act as reducing agent decrease from lithium to fluorine. Here also then sometime you can't understand because reducing agent, that part will be discussed on the calculation. Ability to form cation mean cation. How do we make cation? By adding electron or removing electron? Removing electron. So removing electron easy if the ionization energy is low. From here to here, ionization energy generally, what happens? Generally increases. So when ionization energy generally increases, ability to remove electron decreases. Then ability to oxidize or ability to form cation decreases. Therefore, this statement correct. The ability to oxidize decrease mean ability to act as reducing agent also decrease. You will learn that one under calculation part. All right, let's move to the other side. 2011. 2011, it is given like this. The increase in order of atomic radii of the element carbon, phosphorus, sulfur, arsenic, selenium. Carbon, phosphorus, sulfur, next one, arsenic, nitrogen, phosphorus, arsenic and selenium, oxygen, sulfur, selenium. These are the places. So here to here atomic radius decrease, here to here atomic radius increase. They ask increase in order. The lowest one should be what? Left, rightmost bottom. Smallest one. No, atomic radius decrease. Yeah, then it should be rightmost bottom, top one. And the largest one should be leftmost bottom. But the thing is this one. These are group 15, 16 and third and fourth period. This is group 14, second period. Group 14, second period. Second period should be small. But out of these, then we can have it like that. The smallest one should be rightmost top, means sulfur. After that, phosphorus. Here then smallest one, selenium. According to these trends, we can find it out like that. Then arsenic. Means fifth one, carbon, sulfur, phosphorus, selenium, arsenic, fifth one. This trend will give you correct order. Down increases mean second period one should be the smallest. After that, you can have third period, fourth period. Fourth period larger, but from left to right decrease. Selenium smaller than arsenic. Third period, this is fourth period, this is third period. Third period again, smaller than fourth period. But from left to right decrease means sulfur smaller than phosphorus. Yes. Finally, we get fifth one as the answer. Next, you get several questions from 2009. 2009, which of the following electronic configuration corresponding to the atom with the largest atomic radius among them? If it is difficult to have configurations and then compare, better you think about element. 1s2, 2s2. What is that? It's beryllium. What is next? 1s2, 2s2, 2p6. What is that? It's about neon, 10 electrons. 1s2, 2s2, 2p6, 3s2. What is that? It's about magnesium. Oh, next one, 3s2, 3p2. Magnesium, aluminium, then silicon. Thereafter, 3s2, 3p5 means chlorine. Then they ask, following electron configuration, the atom largest atomic radius. So, the largest atomic radius, where you find? You know, atomic radius decrease. So, the largest mean it should be the leftmost. Down the group increase. Then it should be the bottom. Leftmost bottom means magnesium. The magnesium is given in third answer. If the electron configurations are not comfortable, better you get the actual symbol and the position, then get the normal trend. That way, easy. Another 2009. 2009. Wait. I missed one thing. This is 2009, the second one. Another A-level 2009, I write it here. The first 2009. Number of elements that exist as gases at room temperature. Here, actually, then 11 gases. But that confusion is there again. Organism. By this time, I mean 2009, it was not considered. But now organism is the question. Maybe 11, maybe 12. But rather 11, I mean, hydrogen, helium, what else? Nitrogen, oxygen, fluorine, neon, what else? Chlorine, argon, krypton, xenon, radon. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Those are the 11 gases at this condition, but OG is then quite confused. I mean, still not it's confirmed. Therefore, one can consider it's gas, one can consider it's solid. So maybe, 11 or 12, 4 or 5 according to this. But by that time, they consider only fourth one, 11 gases, except OG. Hari, this third 2009. 2009. This is about the size. Yes, correct. Decrease in order of ionic radii from these things. Can you see all these things isoelectronic? Aluminium 3 plus, F minus, Mg2 plus, what else? Sodium plus, O2 minus. All of these things have 10 electrons. Isoelectronic. But in isoelectronic, I told you radius is inversely proportional to number of protons. They ask decrease in order. Because a decrease in order means increase in order of protons. Increase in order of protons. So there are 13, 9, 12, 11, 8. And then which one is first? 8. Thereafter 9. Thereafter 10, no, 11. Thereafter 12. Increase in order of proton. Thereafter 30. Increase in order of proton will be the decrease in order of the sizes. Where is it? It's in third answer. Yeah. This question, answer 3. Now we have 2008. Again, there are several questions. Which period in the periodic table contain the highest number of non-metallic elements? You have to think about it. I mean, non-metals, down the group, metallic nature increases. For a given group, down the group, what happened? Metallic nature increases. So where you find non-metals, definitely it should be the top one. Because down the group, what happened? Metallic nature increase. So it should be the top one. Top one means first period. First period has only 2 elements, hydrogen, helium. Both are non-metal, but only 2 elements. Then it should be second period. In the case of second period, lithium, beryllium only metals. All the other non-metals. But once you go to third period, sodium, magnesium, aluminium, metals. Thereafter, silicon, metalloid. Then only you have non-metals. Phosphorus, sulfur, chlorine, argon. Only 4. So likewise, when you go to the fourth one, the number of non-metal further decrease. Metals increases, non-metal decrease. You can understand it. So it should be what? Second period. Highest number of non-metals found in second period. Second period given in second answer. Next one also 2008, the two elements which are liquid at room temperature. Did I miss something? Yes, I miss one 2009 question. Okay, I'll come back to that one. A-level 2008, they asked two elements which are liquids at room temperature. I gave it. Mercury and bromine, third answer. Last question, 2008, last one. It's given the correct decrease in order of the radii. When you look at these things, again, isoelectronic, I think, sulfide, chloride, what else? K plus, calcium 2 plus. Is that all? Yeah. All of them have 18 electron, isoelectronic. We apply this one. Radius inversely proportional to proton. They ask decrease in order of size, then increase in order of proton. 16, 17, 19, and 20. Yeah. This is the order. I mean, sulfide, chloride, K plus, and Ca2 plus. Increase in order of proton, that's the decrease in order of size that's given in first answer. So, last one answer, first one. But I missed this one. 2009, the last, no, not last, before this question, before this sizes of ions, there was another 2009 question. I write it here. It's about the variation of the first ionization energy of lithium to fluorine. Easy. That means second period only. The lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Zigzag variation is there. Which one is it? First answer. Lithium, after that boron, then beryllium, after that carbon, then oxygen, and then we have nitrogen. That order, and finally fluorine. It's given in first answer. Those are past paper questions. You see then how easy the questions are given this part in past papers. But the thing is, to answer the questions, you need good understanding about the concept. Second thing, you need to memorize some parts. There are some parts to be memorized. First, understand the concept. Thereafter, keep them in your mind. And there are something you need to memorize. Better to memorize them to answer the questions. Okay. Hari, then I have done everything under unit 1 atomic structure. Okay. So then next week you are going to have unit test. I think you will now face that unit test successful with a very good confidence with these discussions and everything. Okay. See you there. Have a nice day.